just a reminder that our test is Wednesday. And again, that'll be over 6.5, which is the inverse functions. 7.1, which started talking about identities. And then 7.2, which is stuff we're doing now with the sum and difference formulas. And then also those extra problems that I gave you with giving you a couple of points in the graph and then figuring out the equation for the graph, the A, B, C, D. That'll be on there as well. Okay. So we'll do a review on Monday. I have a review sheet and all those good things for you for the Monday. And then also, so test Wednesday, and then Friday we won't have class. Sound like a plan? Yeah? Okay, cool. Friday no class, correct. Before the Friday before spring break, no class, correct. Here you go. Yep. All right. So let's go through some of these problems on this sheet, just so that we are all on the same page with these sum and difference formulas. This is what I have on the docket for today, is just to do these types of problems. Make sure that, like I said, we can understand how to use the sum and difference identities. And then, like I said, Monday we will review for the exam. And that's all we'll do on Monday, and then have the exam on Wednesday. So let's look at number 1 here on the sheet, where it asks you to find the exact value of...
You said exam?
On Wednesday, yes. Yeah, we have exam Wednesday. It is a test, exam, same word. Yeah, they're the exact same thing. I call them exams, but they're the same thing. Yeah. They're the exact same thing. It's going to be over 6, 5, 7, 1, 7, 2. Yeah. And then the extra problems with the graphing. All right, so the first part here in part A asks you to find the exact value of the sine of 165 degrees. So we need to remember our sum and difference formulas. I usually write them when I'm just trying to remember what they are. I write them in a combined form. So I'll write them up here to the side. Oops, it's not a cosine, it's a sine. So we've got one for sine, we've got one for cosine, we've got one for tangent. And technically there's 2, obviously, for each of them. So remember for, oh hey, forgot my S in there, or I erased it, one of the 2. Remember for sine, when you do alpha plus beta, the sign in the middle is the same, so that's why I've got written plus or minus here. I've got the same plus or minus here. The same sign that's in the middle here. And it mixes the 2, right? It does sine alpha, cosine beta, and then flips it. For cosine, remember the sign in the middle is the opposite. That's why I've got plus or minus here, and I've got minus or plus here. So if it's alpha plus beta, you do minus in the middle. If it's alpha minus beta, you do plus in the middle. And then remember for cosine, it's cosine, cosine, sine, sine. And then for tangent, it's the same sign on top, it's the opposite sign on the bottom. That's why we've got plus or minus on top, and minus or plus on bottom. All right. So we'll need those. Make sure you have those for reference for this stuff. You'll need to memorize them for the test, of course, but make sure you have a reference for this one. So we've got a sine of 165 degrees. 165 is not one that we know off the top of our heads. Right? We know 30s and 45s, 60s, and those kinds of things, but we don't know 165. So the trick with this is to rewrite the inside as a sum or a difference of 2 that we do know. Yes? I could do 180 minus 15. The issue is, do I know the sign of 15? Yeah, so 15, you're right. 165 is 180 minus a 15, but I want to make sure I pick angles that I know the sines and cosines of. So one of the big tricks we like to use with this is try to use 45 degrees as one of the angles. because I know sine of 45. If I use 45 as 1, what do I need to use as the other? 120? And 120 is a good one because what's the reference angle for 120? It's 60, right? So I can use, do know sine of 60. All right, so then using your sum formula, how can we rewrite this? What's playing the role of alpha and what's playing the role of beta here? 45 is the alpha and the 120 is the beta? Okay, so how can I rewrite it? Okay, sine of 45 cosine of 120. And then flip it.
You don't have to do these in radian.
Okay, it doesn't matter. We can do them degrees or radians for these. Either works. The formulas will work for whatever angle. As long as we know what the sines and the cosines are. So, to find the exact values, we need to know what the sines and the cosines are, I should say. What's sine of 45 degrees? 1 over square root of 2. And how about cosine of 120? You told me the reference angle was what? 60. So, yes, pi over 3 would be the reference angle. So cosine of that is? That's sine. It's a 1/2, right? And then what quadrant is 120 in? It's in quadrant 2, and the cosine then will be negative. So it's negative 1/2. And now flip it around here. Sine of 120, that one's going to be root 3 over 2. And again, we're in quadrant 2, so that one's going to be positive because it's sine, right? And then cosine of 45 is 1 over root 2. And like I said, for my purposes, that's perfectly fine. You can leave it like that. I don't care if you simplify it. Questions on that one? When you're doing these exact value things, especially using the sum and difference formulas, being able to use that 45 degrees in there somewhere will allow you to split this into another angle that gives you what you need for sine or cosine. Did I actually hit? Yeah, I'm good. We can, if you want. Do you want to? That's the answer, yeah. So we can check whether or not it's positive or negative. I would have to simplify it to do that. Notice that the denominators will be the same, right? I got 2 root 2 for the denominator. So this would be negative 1 on top and plus square root of 3 over 2 root 2. Does it already have a common denominator? It's the same. Should it be positive or should it be negative? We're doing sine of 165. What quadrant would 165 degrees be in? We're in quadrant 2, right? We haven't quite made it to 180. So it should be positive. On top, which number is bigger? Negative 1 or square root of 3? The 1 or the square root of 3? Which one's bigger? Square root of 3 is, right? So this will be positive on top. So it is positive. You're right, you can check it that way. If you want to, you can always check it on your calculator too. Type it in, type this expression in your calculator, and then type in sine of 165 in your calculator. So it give you the exact same number, same decimal. You can check it that way too. This okay? Let's do part B here. This one wants cosine of pi over 12. Again, a good angle to try to put in here is 45 degrees, or in radians, 45 degrees is pi over 4. So if I use pi over 4 first, let's think about this off to the side. Pi over 4. How many pi over 12s is that? 3 pi over 12, right? Multiply top and bottom by 3. I want to end up with 1 pi over 12. This is 3 pi over 12, so what do I need to do to end up with 1 pi over 12? Yeah, I need to subtract the 2 pi over 12, right? Or pi over 6. Yeah. Basically, we're trying to rewrite this in terms of two angles that we know the sine and cosine of. And the way these problems are, they're rigged so that one of them is going to be
equal 15 degrees.
That's equal to 15 degrees. Yeah, that's it. Exactly right. Yep. It's the same concept of using that 45 idea. Yeah. Yep. That's exactly right. You could have this is not the only way you could do this. You could have also used pi over 3 minus pi over 4. That would work. Because that would be like 60 minus 45. You'll get the same answer. No, you better. Otherwise, something's really, really wrong with the formula. All right, so how will we rewrite this one then? Okay. Good. Remember, for your cosine formula, it's cosine, cosine, sine, sine, but the middle sign flips. And then cosine of pi over 4 is, okay, and cosine of pi over 6 is, that's sine. And then 3 over 2, sine of pi over 4, over 2, and then sine of pi over 6 is, that one's the 1/2. And again, I don't care if you simplify it. My goal for testing you on this is making sure that you understand how to use a formula, not whether or not you can simplify the arithmetic. That's why I'm not worried about you simplifying it. That one okay? See if you can figure out part C, and then we'll talk about it. It should have came that way. Sorry. Thought I handed out enough. Where did I put them? Oh, right here. Sorry, I thought I gave enough to them around the back. My apologies. No, I know why. I can't count. I counted 5 when I handed it back. Sorry. That was the issue. I can't count. Sorry. Explains why I'm confused. We're going to talk about this one? Maybe? Yeah? All right. So what do we try? Okay, so pi over 4 minus 2 pi over 3. And how did you come up with that? I agree. How did you come up with it? Yeah.
So I broke it down into degrees.
Okay.
That's easy.
That's fine. You can do it that way.
And it got me negative 75.
Okay.
So I thought of it. I thought of two complementary angles, so that probably would be negative 75 degrees. But I ended up not finding that. So I looked at 120. I looked at quadrant 2. I got 120. I checked it about 45.
Yeah, good. Okay, so using that 45 idea again, right? Okay, cool. So this pi over 4 here is 3 pi over 12, or 45 degrees, but 3 pi over 12. I need to get down to negative 5 pi over 12. So how many pi over 12s do we need to subtract? 8 of them, right? If I subtract 8 pi over 12, I get the 3 pi over 12 minus the 8 pi over 12, and that simplifies to 2 pi over 3 on that right. Does that make sense? We're getting those angles? That's the biggest battle, right? Getting the two angles that you need? Sure. So the reason why we use the pi over 4 is that idea of always trying to include the 45 degrees. That would be, I write it down, that would be the 3 pi over 12 again, right? We need to get to negative 5 pi over 12. That's what we're trying to get to an answer. So what do I need to subtract off the 3 to get to negative 5? So I need to go backwards 8, right? Yeah. And then that simplifies to 2 pi over 3 when I cancel the 4s. Yeah.
Can you do negative pi over 4 minus pi over 6?
Yeah. Yeah, you can absolutely do it that way. You can do a negative pi over 4 and minus pi over 6. That'll give you the same place. There's lots of different ways to do them. You could have also used your trig identity to pull out the negative out in front to start with. Another way to start it. The important part is that you get that negative 5, however you get there. Yeah. So then how do we rewrite this using our tangent formula? Yeah, 2 pi over 3, and then divided by
1 plus tangent of 2 pi over 3.
Is it not? It's not a negative.
where the formula takes into account the minus here, so we don't have to worry about putting it in here too. And then it's tangent of pi over 4, tangent of 2 pi over 3. Tangent of pi over 4 is equal to 1. Tangent of 2 pi over 3, well, the reference angle is pi over 3. So tangent of pi over 3 is root 3, and it's in quadrant 2, so it'll be negative. Yeah. So that in that case, we'll need the negative because the tangent of the 2 pi over 3 is negative. And then it'll be the same values on bottom, right? And again, I don't really care if you simplify it. I mean, this one's not so bad that I can't do it. Questions on this one? All right, let's look at the next problem. All right, so we've got secant of alpha is negative 5/4. Cotangent of beta is negative 5/12. Your alpha is in quadrant 2. And your beta is in quadrant 4. I'm not even going to look at the 3 parts yet. Let's see if we can set up our triangles to help us out here. Because we know that we've got problems like this, we want to use triangles to help us get the values, right? So we draw for alpha, we'll draw a reference triangle over here in quadrant 2. So technically the alpha is that angle, but we always drop our perpendicular down to the axis. What sides can we label for that reference triangle? The adjacent and the hypotenuse, right? What do we label the adjacent? Negative 4. And the hypotenuse will be 5. And it's a 3, 4, 5, so we can add the opposite side we can label with a 3. Everybody see where those numbers are coming from? Since we're given the secant. All right, so beta is down here in quadrant 4. I can make it go either way. I'm just going to write it inside the triangle. What sides, since we're given cotangent, what sides can we label? The adjacent and the opposite, okay. What's the adjacent going to be? 5. And the opposite will be negative 12. Yeah, this one's a Pythagorean triple too. Does anybody know what the hypotenuse is? That's 8, 15, 17. This one's 13. So we have 13 on that one. We've done ones like this before, correct? There's nothing weird about setting up the triangles like this. We've done this, yes? Yeah, Colin? The secant's negative, the alpha's not, yeah. So that's why I could write, actually, you don't know if it's this way or this way. It could be around the other way, too. Yeah, it doesn't matter, yeah. Which I could have made my beta go around this way, too, and it would be the same values, yeah. Because we're just given information about the trig function. Are we okay with the triangles? Did that first before I even tried to answer the questions, right? Got my triangles down? All right, so A wants sine of alpha minus beta. So how can we rewrite sine of alpha minus beta?
Why can't we? I don't know if this is the same question you're asking, but why can't we just go next counter or clockwise rather than going like with the beta?
Oh, you can go either way. It doesn't matter. Yeah, that's what he was asking about. It doesn't matter. You can go. It can go this way, or we don't really know. We're not given that information. All we're given information about is what the trig function of that angle is. So I only drew this one this way because it was the shortest way to get there. I could have gone this way. It could have gone around 8 times before it stopped. We don't really know. We're going to do alpha minus beta. So I have to rewrite this first before I can do it. Because I have to use both of these triangles to help me get this. We don't need to find the actual angles because we're given the trig functions, but I do need to rewrite this expression first using our identity. I need to do that first. How do we rewrite the difference? Okay, yeah, I need to do this part first, right? And then minus Sine beta, cosine alpha. Right? I need to rewrite it using the identity first. Because I don't know what alpha minus beta is, because I don't know what the angles are. I only know what the secant of alpha is and the cotangent of beta is. So I need to rewrite this in terms of just a single alpha, a single beta, and so on down the line. Now I look back over my triangle. Can I figure out the sine of alpha from the triangle? It's 3 over 5. And can I figure out the cosine of beta from the triangle? And that one's 5 over 13. Right? Because I'm just reading those numbers off the triangle, right? Here's my triangle that involves alpha. I need the opposite and the hypotenuse. That's where the 3 and the 5 come from. I'm reading my cosine of beta from the triangle. I need my adjacent and my hypotenuse. That's where the 5 and the 13 are coming from. So what about sine of beta? Okay. Good. Careful. This is cosine of alpha. There you go. Negative 4 over 5. Good. I don't care that you do that. See if you can do the next two. Because you don't have to redraw the triangles. You just need to do the identities for the next two. You ready to talk about this one? So what did you do first with the identities? What did you do with cosine of alpha plus beta first? sat quietly and wished it would go away?
Tangent, tangent alpha minus tangent beta.
That's okay.
I got the cosine. Cosine of alpha times cosine of beta minus sine of alpha times.
Okay, that's a good place to start, right? Get the identity written down. Okay, and then from the triangles, can you figure out the values for each of those? Okay, what did you get for cosine alpha? Okay. Okay. I'm just filling in the values from the triangles. Anybody have any questions about where those values from the triangles came from? Is okay? All right. So tangent of alpha minus beta. Let me move this down a little bit because blend into the other. So for tangent of alpha minus beta, what do we get?
Tangent alpha minus tangent beta.
There we go.
Over 1 plus tangent alpha tangent beta.
Cool. And for tangent alpha, what did you get? Negative 3 over 4. Cool. Is that what others got? Do I care if you simplify that? No. You are correct. I do not care. Anybody have questions on those at all? Again, this problem should look very familiar to the stuff that we've done, right? It's just adding in the piece of having the extra identity to use first. We've done problems where we've had to write triangles in certain quadrants and figure out the other trig functions, right? That's not new. Okay, well, let's go to the ones on the back side. All right, so for the 3a here, it asks you to simplify cosine of inverse sine of 2x plus inverse tangent of 2x. So remember, I mean, this looks weird, but we've done problems like this where we've simplified algebraically expressions that look like this. Remember that when we think about the inverse trig functions, we put in a value and we get out an angle, right? So we can think of this first part, I can think of this inverse sine here as my alpha. I can think of this inverse tangent here as my beta. Right? Remember, inverse trig functions, you put in a value, you get out an angle. I'm never going to actually compute what the angle is, but that's how I can think of it in terms of inputs and outputs for the inverse functions. So we draw some triangles again. If we have alpha equals inverse sine of 2x, how can I rewrite this equation so I don't see the inverse function? How can I rewrite the equation? Now remember, the inverse, it doesn't mean 1 over for that notation, right? So what do we do? So you do the sine of both sides. So you have sine of alpha equals the 2x, right? Do the sine of both sides. And now let's draw a triangle. I know something about sine alpha. For the triangle, what sides do we label if we know the sine? Opposite and the hypotenuse, right? So what can I label the opposite and what can I label the hypotenuse here? Good. The opposite is a 2x and the hypotenuse is 1 because I can think of it as 2x over 1. Can we figure out the third side? In terms of x, can we figure out the third side here? Good. Yep. Pythagorean theorem, right? That'd be 1 squared minus the quantity 2x squared. That's where 4x squared is coming from. What if we did the same thing for beta? Beta is inverse tangent of 2x. So tangent of beta is 2x, just like what we did in the previous one. What's my triangle going to look like this time? What sides can we label? Okay. It's tangent that we're given, right? So we'll label opposite and adjacent. What's the opposite going to be? And the 2x, and then the adjacent will be 1. And again, can we figure out the third side? Yeah, good. It'd be square root of 4x squared plus 1. Good. Notice that this looks a lot like the previous problem, doesn't it? We had to come up with the triangles first. It just has letters instead of numbers. Looks a lot like it. So this is, if I rewrite this, like I said, I can think of this as alpha and this is beta. So I want cosine of alpha plus beta. How can we rewrite that using the identity? Good. And now this really does look like the previous problem. Again, just with letters instead of numbers. I want cosine of alpha. Look at your triangle. What is your cosine of alpha going to be?
Root 1 minus 4. I mean, square root 1 minus 4 squared over 1.
Over 1. Good. So just square root of 1 minus 4x squared there, right? And for cosine of beta? Good. Right, for the first one, we're just doing, for the first one, we're using the triangle that's involving alpha, and we did adjacent over hypotenuse. For the second one, we're using the triangle involving beta, and again, we did adjacent over hypotenuse. Okay, so for the second part then, we want sine of alpha and sine of beta. What's sine of alpha? 2x. And what's sine of beta? Good. Questions about that one? Do you see how it relates to the previous problem? Right, because the previous problem, what were we given? We were given secant of alpha was negative 5/4, right? In this problem, what are we given? We're given that sine of alpha equals 2x, right? Similar information, isn't it? What did we do in the previous problem? We made a triangle. Right? And we labeled those sides because we were given information about alpha and the secant, correct? In this one, we don't worry about quadrant when we've got these with variables in it, which is why I just drew a triangle over here. But again, we're given information about the sign, so we labeled the opposite and the hypotenuse. Right? And then, just like we did over here, you would use the Pythagorean theorem to fill in the missing side. We use the Pythagorean theorem to fill in the missing side. And then we use the triangle to fill in the values. It's the same problem, just with letters as opposed to... It's written in a different form, but it's the same problem. And it's got letters as opposed to numbers in it, but it literally is the same problem. So see if you can do part B there. You have to draw new triangles, of course, but see if you can do part B. Tangent of inverse cosine of 3 over x minus inverse sine of 3 over x. Let's go ahead and talk about this one just because we have 5 minutes left. And I want to make sure we get done with it. So again, remember that when you're doing the inverse functions, right? We think about it as putting in an angle and getting out putting in a value and getting out an angle, right? So I think about first piece is say alpha, second piece is beta, and let's see if we can get triangles for alpha and beta. So if alpha equals inverse cosine of 3 over x, how can I rewrite that equation? Good. So if we draw a triangle again, what sides of the triangle can we label? Okay. Good. Good. Close to the same thing as the sine, yeah. Should just be a slightly different. There should be a flipping of a couple of things, but yeah, same idea. Do we see where this is coming from? All right. First thing I did was just rewrite the equation and then just set up the triangle like we've done before. So it's going to have cosine of an angle is 3 over x. I know that if I put that angle in a right triangle, I know how to label its adjacent and its hypotenuse. So let's do the same thing for the sine. If we have sine of, beta equals inverse sine of 3 over x, how can I rewrite that equation? Okay, sine of beta is 3 over x. Oops, that looked ugly. So what sides can we label here? Opposite is 3. Yep, the hypotenuse is x, which makes the adjacent the square root of x squared minus 9. So the triangles look similar. Just got the adjacent and the opposite sides flipped, right? So this is tangent of alpha minus beta is what we're interested in. Okay. Okay, good. That's our difference formula for tangent, right? Now looking at the triangle, can we figure out tangent of alpha? It's going to be okay, because we're doing opposite over adjacent, right? And then for tangent of beta, good. And good. Yep. And for me, that's good enough simplifying. Don't care if we simplify it more than that. You can. I mean, that part of the denominator is going to simplify to, the whole denominator is going to simplify to 2, right? So it's not too bad to simplify, but I don't really care that you do it. Is this okay? There's a couple of identities on there to verify. I would work on those. You're going to verify the identities just like we did for other ones. You just got some new identities to play with, right? So work on those. I'll get answers posted to these on Moodle for you so you have them. Again, on Monday, we'll review for the exam. We've done all the material that we need to do for the exam. We'll do that on Monday. I'll have a review sheet we work on. And an exam Wednesday. So we will see you then.
Thank you, Mr. Stevens.
Yep, see ya. I see. Split the wire.